Hello and welcome to the section on quadratic formula and graphs. We're going to graph these things after learning a nifty little formula. Let's get to work. This equation right here, up until now we've been like, hey, can we factor this? No, but we do have a different way to do it, and that is completing the square. So what we would do to complete the square on this one is we'd have to move this constant term over there. So we get 3x squared plus 5x equals a negative 7. Get the leading coefficient down to 1, so divide by 3, and that guy's gone. So we have x squared plus 5/3 x, leave a space for the special number that will complete our square, equals a negative 7/3. Okay, so now we've got to put a special number in there, half of this number, which is 5/6, and then square that 25/36 on both sides, plus 25/36 on both sides. Now what we have created is x plus 5/6 all squared equals, and then we look over here and we're like, ooh, that's a fraction. Yeah, we've got to, in order to add these fractions, common denominators, so we've got to times by 12, times by 12. So we have negative 84 plus 25. Negative 84 plus 25 is negative 59. So it's negative 59 over 36. Yeah, that's a little ugly little thing, isn't it? So now we have a perfect square. We can square root. What do we not forget there? Plus or minus. So we get x plus 5/6 equals plus or minus square root of negative 59 over 30, square root of 36 is 6. That came out nice, good. And the square root of a negative, that negative will come out as an I. So now subtract that over and we get x equals a negative 5/6 plus or minus I square root of 59 all over 6. These have a common denominator and we can add those fractions to x equals negative 5 plus or minus square root of 59i, or I square roots of 59 all over 6. Wow, that gets really intense. After you've done a few of these problems, you start to think, man, we're doing the same thing every time. And it's true, you are. So somebody came up with this great idea. Instead of 3s and 5s and 7s, we could do the same thing, but let's put, something like let's put A's and B's and C's right there. And if we put A, B, and C and then watch where they end up, we could have a formula and never have to do all this process again. Oh, that would be nice, wouldn't it? So let's do that and see what happens. We're going to do the same thing, subtract the C over and divide by A. Let's go ahead and do those at the same time. B over AX equals a negative C over A. Cool. Okay, so I just did those first two steps at the same time, got leading coefficient 1. Now we have to take half of B over A. Now, you might have to do this by hand over here. Half of B over A, that's 1/2 times B over A is B over 2A. That's half of it. And so if we square this, we are adding B squared over 4A squared to both sides. Ooh, yeah, look at that. That's kind of tough there. So what happens when we add both of those together? Well, on this side, we now have a complete perfect square. So we'll write that down. And yeah, you can actually multiply this out and you'll get x squared plus b over ax plus b squared over 4a squared. So on the other side, what do we have? We got to get a common denominator. We used a different color for that. So let me see. We'd have to times by 4a times by 4a on top and bottom there. So we get here negative 4ac plus a b squared all over 4a squared. Okay, common denominator, added the fractions. Excellent. Now what we can do, look at this. We're here where we have a perfect square. So we can square root plus or minus x plus b over 2a equals plus or minus the square root of, and negative 4ac plus b squared is the same thing as b squared, and then negative 4ac, or b squared minus 4ac, over square root of 4 is 2, square root of a squared is a. Unless a is negative, then it's negative a, and the plus and minus would change, but that's all right. We already have a plus or minus there. Good. Now all we have to do is subtract the b over 2a over, and we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Oh, look, common denominators. So I'm going to write this in this bright color here. When we add the fractions together, we have this kind of formula. Well, it is a formula. This is the pattern on what you would do if you completed the square over and over and over with any random number a, b, and c, or any random set of numbers there. This is called the quadratic formula. X equals negative b plus or minus b squared minus 4ac all over 2a. You'll notice what, if we would have known this ahead of time, this equation right here, the 3, put it in for the a in both places, the 5 in for the b, and the 7 in for the c, and we would get x equals negative 5, there's the b, plus or minus, b squared is 25 minus 4 times 3 times 7. 4 times 3 times 7 is 84. And you have 25 minus 84 is negative 59. That's where that negative 59 came from. All over 2 times 3 is 6. Isn't that snappy? Look at that. This is a formula. And it will solve every single quadratic equation. This is amazing. Just like you could always use this process of completing the square, here you can jump to the answers. You may need to simplify square roots and stuff like that, but it's so famous that it actually has a song that goes to it. I'll try my best. X equals negative b plus or minus square root b squared minus 4ac all over 2a. There's also a rap. Unfortunately, your instructor does not rap well, so I'll give you the words. Negative b is where you start, plus or minus to show you're smart. Then that radical sits so neat over b squared minus 4ac. Then you're done, except to say everything sits on top of 2a. Thank you, thank you. What a performance. Okay, now getting back to it, let's do a couple more and see how they would work. So here's how you would do one with the formula. 2x squared minus 5x plus 1. Here's your a, here's your b, here's your c. So your answer would be x equals negative b. So that's a positive 5. So b is a negative 5 right now. X equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. All right, so this would be 5 plus or minus the square root of 25 minus 8, which is 17, all over 4. And those are your answers right there. 5 plus the square root of 17 over 4 and 5 minus the square root of 17 over 4. That formula is as slick as can be. Let's do another one so you can kind of see how it works. Let's do something like 6x squared plus 17x plus 5 equals 0. Oh yeah, look at this guy. If we were to do this one, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Oh boy, this may take a little bit of simplifying here. Negative 17 plus or minus the square root of 289 minus 4 times 6 times 5. 4 times 6 times 5. 4 times 6 is 24, times 5 is 120. So this is a 169 all over 2 times 6 is 12. What's 169? That's 13 squared. So that comes out actually nice. Negative 17 plus or minus 13 over 12. Oh my word. Sometimes you'll simplify down and get imaginary numbers like we had with the square root of 59 with an I. Sometimes you'll get irrational ones. And sometimes you'll get perfectly fine Yeah, you'll get just perfectly fine rational numbers. Negative 17 plus 13 is a negative 4 over 12 is a negative 1/3. And negative 17 minus 13 is negative 30 divided by 12. Negative 30 divided by 12, that looks like 5/2. You know what this means? We got two rational numbers. That means we could have actually done this problem by factoring. This, it looks like, would have factored to 5x minus 2 and x, no, 3x plus 1. Did that really factor? Yeah, 6 times 5 would have been a 30. We would have broken it up into 2 and 15 and then factored it. And yeah, look at that. That would have given us these numbers exactly. That's crazy. While we're here, before we let you try some on your own, we want to note that this square root really determines a lot of stuff. If it's positive, and so underneath here, this b squared minus 4ac, it's often called the discriminant. If it is less than 0, let's talk about that one first. If it's less than 0, then negative, then we're going to get imaginary roots. Yeah, these numbers will be complex. This guy will be imaginary. If it is equal to 0, if that just happens to come out equal to 0, then the plus and minus goes away and you will have one fraction as an answer, and that's that negative b over 2a. If it's bigger than 0, it could come out to be like a 17, or it could come out to be like a square root of 169. It could either be rational, like this guy down here, or it could be irrational, but it would at least be real, and there will be two separate ones. So that's kind of called the discriminant, because based on where it lies, less than 0, equal to 0, or greater than 0 in a perfect square, greater than 0, not a perfect square, it will determine which kind of answers you have. That's kind of neat to keep in mind, that what you get under the square root sign will make that determination. All right, let's give you a try on your own. To the boards! Here are some problems for you to write down, put in your video notebook. Press pause, give them a try. Use the formula x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now remember, you will have to get it equal to 0 first, so don't make that mistake. Go ahead and pause the video, and when you're ready, hit play. All right, here we go. Here we have a is 1, b is 4, and c is negative 21. It is equal to 0, so we have x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, let's simplify this down. Negative 4 plus or minus the square root of, this is 4 squared, 16, plus, notice that negative and that negative will make a plus 84. 16 plus 84 is 100 all over 2. Hey, wait a second. Square root of 100, that comes out exactly right. Negative 4 plus or minus 10 all over 2. That's going to equal negative 4 plus 10 is a 6 over 2. That's 3. And negative 4 minus 10 is negative 14 divided by 2. Let's write that down. Negative 14 divided by 2, that's a negative 7. Oh my word, look at that. X equals, there's our answer. But holy cow, that means we could have factored this into like x minus 3x plus 7. Right on. Answers. All right, number 2. We've got 3x squared equals 8. Got to get it equal to 0 to use this formula. So we get 3x squared minus 8 equals 0. So a is 3. B is not in existence. It's not there. It's a 0. So we're going to do x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. Good. So we get x equals plus or minus the square root of, what is that, 96 all over 6. Square root of 96. That simplifies to, let me see, what is 96? There's There's a 4 that goes into it, so it'd be square root of 4 times 24. Okay. Oh, this still has a 4 in it. That's 4 times 6. Okay, so it's 2 times 2, 4, square roots of 6 over 6. The 4 and the 6, you can take a 2 out of both of them. And so we get equals 2 square roots of 6 over 3, plus or minus. There we go. Don't forget that little plus or minus thing. Plus or minus 2 square roots of 6 over 3. Fascinating. This one deserves just a little bit of time to see what happened here. You could have divided by 3 and then took the square root of both sides. Look at that with a plus and minus. And we would get x equals plus or minus the square root of 8 is 2 square roots of 2 when simplified over the square root of 3. Do we leave square root of 3 by itself on the bottom? No, we rationalize the denominator. So if we times by square root of 3 and square root of 3 like we did back in the last chapter, we get x equals 2 square root of 6 all over square root of 3 times square root of 3 is 3. Not that it saved us any time, but it was fascinating to watch how that this formula really will solve every kind of quadratic equation. That's pretty slick. Okay, the last one. We need to rewrite this as 5x squared plus 2x plus 4 equals 0. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Oh, good. So now we have x equals negative 2 plus or minus the square root of 4 minus 4 times 5 is 20 times 4 is 80. 4 minus 80 is negative 76 over 10. So x equals negative 2 plus or minus, let me see, that'll come out as an I. 76 is 4 times 19. So that's 2 square roots of 19 all over 10. It looks like there's a 2 in the top that could be factored out. I'll do that in really slow motion. If we take a 2 out of the top, we get negative 1 plus or minus I square roots of 19 over 10. And this 2 now is a factor, so it can cancel with the bottom and leave a 5. So it is negative 1 plus or minus I square roots of 19 over 5. These are imaginary or complex, that has an imaginary part. These are complex numbers where our answers are. Fascinating. Now, we used to write as a plus bi, so you could write as negative 1/5 plus or minus square root of 19 over 5, and then put the I out there. Either way would be the same one. Excellent. Nice job. Next on our docket here is graphing. Now you should remember back when we did lines, we had y equals mx plus b. These were linear equations because this thing created a line with a constant slope, and then we had this intercept over here. When we're dealing with quadratic, when we're dealing with quadratic, that means we have a square. That's what quad is. So we have something with squared. So we're going to have y equals, or f of x equals, we're going to have an ax squared plus a bx plus a c. Now you may think, hey look, the quadratic formula will help us. Well, it will if we put a 0 here. Or if we put another number and subtract over to equal 0, then yes, we get to use the quadratic formula. That's awesome. But before we get to that point, let's first find out a little bit more of this is a line. This, not a line. So if this was a line with a constant slope, not there. So we first have to realize that we do not have a line. So let's look at what shape this is to begin with. X squared, the very basic quadratic function. Let's do a little XY plot here, and let's see what happens. So I'm going to start out with about negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. That's a lot of them, and you'll see why I did so many. If I stick negative 4 in and square it, let's write f of x over here as well, so you remember that y and f of x are really the same thing. We stick in negative 4 into this function, and we get positive 16. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is indeed 16. What does that look like on a graph? Well, -4 is way up there at -16. -3 is -9. So it's coming in really, really steep. -2 is -4. -1 is -1. 1 is 1. Oh, a little bit bigger there. 0 is 0. 2 is 4. 3 is 9. And 4 is 16. We learn a couple of things about this. Number one, it is coming in and the slope, ooh, I'm not even hitting the dots. The slope is changing. So we do not have the concept of a slope going on here right now, except the slope, the steepness, keeps changing. The second thing is that it is a U shape. And so there is a point right down here where it turns a corner. That is called the vertex. So that's crucial. When we graph this, you could stick in a bunch of points like this. That is the old way to do it. Just like y equals mx plus b, we could have graphed a bunch of points. But when we started saying, hey, let's find the intercept, let's find the slope, those were the shortcuts. For this, we are going to end up finding, yes, definitely the intercepts. That's the crucial thing. And then, similar to that, we are now going to find the vertex. That's the crucial thing that will help us know where this U shape begins, is if we can find that point right there. You should also note that around the vertex, it is symmetric. Meaning, you know, we were up here at 3 and down here at -3, and we got the same y value. So it is symmetric. So if you can find two of these values and average these guys, you'll be right here in the middle at the vertex. So let's see how this kind of works. If we did something like f of x equals x squared minus 4x minus 12. Let's do something like that. We could, if we wanted to, run through all of the x and y, you know, things and start sticking in like -4, -3, -2, -1, 0, 1, 2, 3. And we could do that. But there are specific points that will help us identify where the U is without going through all that process. So we're not going to do all of those. We are going to do one of them though. We're going to find the intercept certainly. If you do f of 0, this is sticking in x is 0, so this will give us the y-intercept. That is going to be 0 minus 4 times 0 minus 12. Just like y equals mx plus b, this is slick. This gives us -12 as an answer, 0, -12. So on our graph, we'll put it right down here, 0, -12. That is one of the points. Now, to find the other intercepts, we've got to stick 0 in for y. That is this guy right here. When we stick in 0 for y, yes, now we've got a 0 right here, and we could use one of 3 ways to solve this thing to find the x's. Notice we're going to have 2 of them. Yeah, if this is a U shape, we're going to have 2 different x-intercepts, which makes sense. When we solve this, we had a plus or minus all the time. We have 3 ways to solve it. We could solve this by quadratic formula. That's the end result. The last resort, if we can't solve it any other way, we could always use that one. We could solve it by factoring to see if it works, or we could solve it by completing the square. Those are 3 different ways, and they will all provide the right answer. If it's factorable, all 3 of them will work. If it's not factorable, completing the square and doing the formula will work. So I'm going to first of all factor, and so we can see it, and then we'll work it out with the formula so you can see a little bit more about how this will work. So factoring, is there anything that times to -12 that adds to a -4? Yeah, x minus 6, x plus 2. That equals 0. And we solve this and we get x equals 6 and x equals -2. 6 and -2 are what we call roots of this function right here. The zeros, meaning when you stick them in, you get zeros out, also called X-intercepts. I'm going to write that right here, the X-intercepts. So if we have 6, 0 is right there, and -2, 0 is about right there, we can kind of see that we already know that it's going down like this, and then it's going to come down here and turn and come back up. See, the y-intercept isn't right in between these two, so the turnaround point is not there. But we can, by these 3 points, kind of tell where we are. We just don't know how far we go down here. So the last thing we're going to do is how to find the vertex. Now, what I need to show you on this, and we'll go back and solve this with the quadratic formula here in a minute. But vertex, we know that this guy at 6 and this guy at -2, they're at the same level. They're x-intercepts. They have to be right around this line. And here's where the key in the vertex is. This guy, its x value has to be the average of the two intercepts. The average of those two. So if we were to take 6 plus a -2 and divide it by 2, 6 plus a -2 is 4, divided by 2 is 2. It is 2 something. There's the vertex. And so right here, 2 something. How do we get that? How far down it is? Well, that is the other 1 point that we will stick in here. So we are actually going to stick in 0 for y, and we'll get the two x-intercepts, and then these are the two x points that we're going to stick in. 0 to get in the y-intercept, and 2 to get the vertex. So let's stick in f of 2, and let's see what we get. F of 2 equals 2 squared minus 4 times 2 minus 12. So we get 4 minus 8 minus 12. 4 minus 8 is a -4, minus 12 is a -16. So that's where the vertex is. All right, now let me show you how the quadratic formula may be very beneficial in this case. If you were to do the quadratic formula, you would have x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a, like that. Okay, good. So when you do this, and this will always happen this way, 16, oh, that's at 12. Sorry about that. 16 plus 48 gives us 64. So we get 4 plus or minus the square root of 64, which is 8. Let's write that in, all over 2. 4 plus 8 is 12, divided by 2 is 6. Oh my goodness, look, we got 6. And 4 minus 8 divided by 2, that's -4 divided by 2 is a -2. Oh, look at that. Those are the same things. We got an x-intercept at -2, 0, and at 6, 0. So yes, if you can factor it, great. If not, that's fine. But I wanted you to notice something here. Whenever you do a plus and minus on these, you're always doing the center plus something and minus that same thing. So there's actually a shortcut. Let's write this up here. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. These will be the x-intercepts when you stick 0 in right over here. When you average these two numbers, you will always get this right here. That's exactly right. You can skip all the way to finding the vertex by just doing -b over 2a. So here's another one. Let's see how all this works together. So first of all, in graphing this, we've got to find the x-intercepts. I mean, all the intercepts. So the easiest one in the world is g of 0. We get, so this is the y-intercept. There we go. G of 0, stick it in, we get 0 plus 6 times 0 minus 2. We get a -2. So the point 0, -2, right there, 0, -2, that's our y-intercept. So that's one of our points, whether we're coming this way or that way. I don't know which way we're coming, but that's where it is. Okay, so now let's find the x-intercept. So we stick a 0 in for y, and we get x squared plus 6x minus 2. We could complete the square or use a quadratic formula, but this guy doesn't factor. Nothing times to 2 and adds to 6. So quadratic formula, here we come. X equals -b plus or minus square root b squared minus 4 times a times c all over 2a. Oh, I like that. That's pretty nice. So that is going to give us -6 plus or minus the square root of 36 plus 8, which 36 plus 8 is 44 all over 2. So that's -6 plus or minus 2 square roots of 11 all over 2, which equals -3 plus or minus square root of 11. Now you might need to use a little bit of your calculator here to see that -3 is about right here. So I'm going to put a little line here at negative 3. Plus the square root of 11 would be about right there. Punch that in your calculator and you'll get a decimal. I know that it's positive because the square root of 11 is bigger than 3. So negative 3 plus something bigger than 3 is going to be positive, and negative 3 minus that amount will be just on this side of negative 6. Good. Okay, so this is negative 3 plus the square root of 11, 0. And negative 3 minus the square root of 11, 0. Now, if you've never seen that before, if you actually stick this irrational number in for x, negative 3 minus the square root of 11, and you square it, then you take 6 times that number and add it to it, then subtract 2, you will actually get 0. And these are the only two numbers in the known universe that will solve this quadratic equation. Fascinating. Alrighty, so can you see kind of where it is? It's coming down here like this and coming down here like this and then coming, oops, I'm going to come in this way so I can get that curve right about where it needs to. Let's draw that one more time. Okay, so if we're coming down here like this and then it's going to curve up and go like that. Oh, close enough. Good. Now, and this is what I meant. We got to find one last point, and that is the vertex. Well, when you get these two X-intercepts, if you average them, we'll do it the long way first. Negative 3 minus the square root of 11 plus negative 3 plus the square root of 11 all over 2. These are conjugates, so they're add and subtract cancel, and we get negative 6 over 2, which equals, oh, look at that, negative 3. That's kind of weird, but yeah, it kind of makes sense. This guy was found by negative 3 plus the square root of 11, and that guy was found by negative 3 minus the square root of 11. Because these solutions always come in conjugate pairs, this number right here is the middle of them. That will be the x value. And so we do have to stick that in. There's no other way around it. G of negative 3 equals negative 3 squared plus 6 times a negative 3 minus 2. We actually have to stick that in. 9 minus 18 minus 2, and that gives us negative 11, I think. So negative 11. And you will often see this number come up somewhat similar in there. Not enough to make a guess as to where this is. Actually stick it in, but there's the vertex right there. So that is what you'll be asked to do, is to graph these, finding the X-intercepts, the Y-intercept, and the vertex. So the intercepts and the vertex. Let's do one more to see how it works. Before we jump to there, let's watch and see how you could have used negative 6 over 2 times 1 to give you that negative 3. There's that shortcut, negative b over 2a for the vertex. Let's write that right there. Negative b over 2a will always give you the x coordinate of the vertex. All right, let's do one more. All right, here's our last one. We have p of x equals 2x squared plus 6x plus 7. All right, let's do it. The y-intercept, p of 0. Easiest one. 2 times 0 squared plus 6 times 0 plus 7. So we get 0, 7. That's one of our points. Nice. Okay, now let's stick in 0 for x, and we get 2x squared plus 6x plus 7. 2 times 7 is 14. I'm not seeing us get a 6 out of that. I don't think this will factor really well. So, quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Good, so this is negative 6 plus or minus the square root of 36 minus 56. 4 times 2 is 8 times 7 is 56, so this is negative 20 all over 4. So this is negative 6 plus or minus. This is 4 times 5, so we get 2i square roots of 5 all over 4. That gives us, let me see, we could take a 2 out of everything and we get negative 3 plus or minus I square roots of 5 all over 2. Well, this is kind of a little bit of a problem. Well, not a problem, but something for us to know. This has imaginary or complex roots, so non-real roots, which means that the U shape that we end up with we're up here at 0, 7, that we are going to end up not having X-intercepts on the real number line. So no X-intercepts in this one. Because, yeah, this discriminant, this b squared minus 4ac, it ended up being negative. So we end up with imaginary portion here. So we will only be able to find the vertex and this y-intercept to be able to go. So let's try, let's find the vertex. So negative b over 2a is what goes in right here. And you'll notice it is right here on the x-intercepts. Negative 6/4 simplified down to negative 3/2. So I'm going to put negative 3/2 there. And then what's the other one? You have to stick it in. So p of negative 3/2. That means back here at negative 3/2, somewhere up or down from here is where the vertex is. And we're going to find out where it is. 2 times negative 3/2 squared plus 6 times negative 3/2 plus 7. Let's see where we are. This is 2 times 9/4 plus, that looks like a negative 9. Yeah, plus 7. Okay. That's 9/2 minus 9 plus 7. So if we turn all these into halves, 9/2 minus 18/2 is negative 9/2. Plus 7 is positive 5/2. So that is the output for sticking in negative 3/2 in for x. We get that output. So we're up here at about 5/2. And so that, come down here and make it a u, not a v. And that's our parabola. We don't have any x-intercepts, and you can see that in the imaginary root. Okay, you guys can now try this on your own. To the boards! Here are some to put in your notebook, and you need to know the x and the y-intercepts and the vertex. That will be a total of 4 points that you're going to find. Try these, give them a shot, press play when you're ready to see how you did. Okay, welcome back. Let's give these a shot and see what it did here. So first of all, let's do the y-intercept. That's the nice one. You stick in 0, f of 0, and you get 0 plus 0, negative 6. So 0, negative 6 is a point. Good. The x-intercepts. We're going to stick in 0 for y. So we get 0 equals x squared plus 5x minus 6. We could use the quadratic formula unless we can find a way to make this thing factor, and we get an x plus 6, x minus 1, and indeed, look at that. We don't have to use the quadratic formula if we can find another way, so we get x equals negative 6, x equals 1. Yes, so that means negative 6 will give us a 0, and 1 will give us a 0. So 1 is right here, and negative 6 is clear back there. Oh boy, so we can tell that we are coming down like this, and we're going to turn around somewhere and head off up there. Those are, of course, straight U-shaped things. Good. That's a 1, 0, and that's a negative 6, 0. And that guy right there is 0, negative 6. Fascinating. Okay, so now we got to just find the vertex. So we can either average these. Negative 6 plus 1 is negative 5 divided by 2 is negative 5/2. That's one way you can see what the x coordinate is. Or you can take that negative b over 2a thing. Negative 5 over 2 times 1 will give you negative 5/2. Cool. Well, let's stick it in and see what we get. F of negative 5/2. That's going to be negative 5/2 squared plus 5 times negative 5/2 minus 6. So we get 25/4 minus 25/2. Let's put that minus sign. 25/2 minus 6. So if we make these all fourths, 25/4 minus 50/4 is negative 25/4. Minus 24/4 is negative 49/4. Negative 49/4. And there we have it. Right there. That's the vertex. Okay, next one. Okay, g of 0. That is 2 times 0 plus 8 times 0 is a negative 1. 0, negative 1. Yay, we found one. I love it. Okay, now let's stick in 0 for y. 2x squared plus 8x minus 1. Does this have any hope of factoring? 2 times 1 is 2. Not so much. So quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Oh, good. Let's see what this simplifies down to. Negative 8 plus or minus square root of 64 plus 8. That's a 72 all over 4. Now, the square root of 72, this is 36 times 2. So we get negative 8 plus or minus the square root of 6 square roots of 2 all over 4. We can take a 2 out of everything, so we get negative 4 plus or minus 3 square roots of 2 all over 2. Okay, let's stop right there. And if we were to punch these guys in the calculator, we would have negative 4 plus 3 square roots of 2. Okay, let's plug it in the calculator to see what we get here. Negative 4 minus 3 square roots of 2, and divide that whole thing by 2. So we get the first one is about negative 4.21, so somewhere back over there. And now let's try the other guy. Negative 4 plus 3 square roots of 2 divided by 2. And we get like 0.121. So this guy's going to be just barely right there. So we're going to come in like this, and it's going to go and come back up, something like that. So the only one left is the vertex. All right, so what's in the middle of these two guys? Well, those are nasty looking numbers, but the middle is right here. If you throw off the plus or the minus, it was right here with some plus and some minus. And so the middle is, and you could do it by negative b, which is negative 8 over 2a, 2 times 2, which is 4. So it becomes a negative 2, negative 4 halves right there. And let's stick it in, g of negative 2, and that equals 2 times a negative 2 squared plus 8 times a negative 2 minus 1. 2 times 4 is 8 minus 8. That's minus 16. Sorry about that. 8 minus 16 minus 1. So we get negative 9. Wow, look at that guy. Wow, 2, negative 9. There's the vertex. So we have the X-Intercepts, the Y-Intercept, and the vertex. Excellent. Okay, last one. H of x equals x squared plus 6x minus 4. Can we factor it all? Yeah, that's not going to help us with our x-intercept. So let's get our y-intercept. H of 0 equals 0 squared plus 6 times 0 minus 4 equals a minus 4. Oh, I like that y-intercept. That's nice. That makes you just feel good about life. 0, negative 4. So if we stick in the 0, we get x squared minus plus 6x minus 4. Just for kicks and giggles, let's do it by completing the square. We know how to do it. We've done this one with quadratic formula. Let's complete the square. Add 4 over here. We get x squared plus 6x. And we've got to add something to both sides to make it look nice. What would that be? Half of 6 squared is 9. So we'd add 9 to both sides. So then we get, this is x plus 3 all squared equals 13. Square root, plus or minus. So we get x plus 3 equals plus or minus square root of 13. X equals negative 3 plus or minus square root of 13. Okay, so negative 3 plus the square root of 13 is up here, minus the square root of 13 will be down there. Again, you can plug that into your calculator to get those decimal approximations if you'd like. And those are the two x-intercepts. So we can see we're going to be doing something like this and something like that. Hey, that turned out a little bit better than my other drawings. Okay, so this guy right here, what is it in the middle? Well, there it is. Negative b over 2a gives us negative 3. And stick in negative 3, h of negative 3. We're in h right now, negative 3. And we get equals negative 3 squared plus 6 times a negative 3 minus 4. 9 minus 8 is a negative 18, is a negative 9, minus 4 is a negative 13. And there we have the vertex. Nice job. You're ready to move on to the next section. And for the final installment of this quadratic formula in graphs, we found out how to solve with the formula and how to graph. Now, everything that we have told you about graphing is true. It is possible, however, that when you see it, it won't be in your little ax squared plus bx plus c equals 0 or equals f of x to be able to graph it. And there's a common way that it will be written. If you have something that looks like, I don't know, f of x equals, and they've completed the square, x plus 4 altogether squared minus 2, you can actually FOIL that out, x squared plus 8x plus 16 minus a 2, and you'll have it in your ax plus b form. This, however, right here is actually pretty handy. So we're going to explore this a little bit and then come back here and solve this. Here we are in an online graphing calculator type thing, and I just wanted to use this. You don't get to use this on your test necessarily, but it's really good to see what's going on. So y equals x squared, we see, is this parabola. We've graphed that thing before, but instead of putting like something A and a B and a C there, we're going to watch and see how when you put numbers in this form, perfect square form, how it adjusts things. So we're going to do another graph here, y equals x squared, and then let's add the k on this end. So right now, we're going to put, well, let's put a number there first. So I want you to notice what happened. This is the black one, where it used to be here at 0, 1, 0, 0, notice that we're now 1 bigger. Where we used to be at 1, 1, negative 1, 1, we're now up here at negative 1, 2. When we used to be here at 1, 1, we're now 1, 2. So what happened was that everything that we used to get out for y is now plus 1. So it raised it up 1. It moved the whole thing up 1. What do you think would happen if we put a 2 here? It moved it up 2. You can even see stuff like if we're at 3, we were up at 9 before, and now we're going to be up at 11. I mean, it looks like they get closer and closer, but the vertical move is 2. What would happen if we did like a negative 3 here? It moves everything, the entire x squared, down 3. So to see how it works here, we're going to put a plus k, and this cool little thing says, do you want a slider there? Yeah, let's do it. If k is 1, it's going to let us move this up and down on the numbers so you can see it. As k gets bigger, it slides it up. As k gets smaller, it slides it down. And that's exactly what happens with that k there. That's kind of neat. I like it. So now let's do another one. Y equals, and let's see what happens if you put something in the middle there, like an x plus 2 altogether squared. Ooh, it moved it 2. What if you move it 3? How about 4? Do you see each number in here moves it to the left 1 more? That's kind of weird. We put in a plus 5 here, and look at that. It scooted it all the way left 5. And well, why is that? Well, unlike this one, where here you used to get things out for y, now we get out things, the k just adds things right onto the y, adds them on, adds them on, adds them on. This one works a little bit differently. This is adding stuff onto the x before you get a y value. So in other words, what we used to stick in 0 right here to get 0 out, now what do we have to stick in to get 0 out? Well, we have to stick in negative 5 to accommodate or counterbalance the plus 5. So it actually moved it left. So what would happen if we put in a negative 5? Where would it go? And it's right up here. It moved it to the right 5. So many people will leave that as a negative and put this little h in there and say, yeah, let's put in this slider. And as h gets bigger, because we've now put it in as a minus sign, it will actually slide to the right as we move to the right. So if we're at 10, that means we have slid right to the 10. So there's a minus h here and a plus k there. So that's pretty cool. So we will actually, let's do this. Let's add the k right there. And, that's an equals. Plus k there. And then let's get rid of this guy right there. I like that. Yeah, that's nice. There we go. So now the K will scoot it up and down, and the H will scoot it left and right. Oh, that's pretty fancy. So let's put these both back at 0 and see what happens if we put something out in front. I just put something out in front, an A out in front here. Now watch what happens if I start moving this guy. See how he gets thinner and fat? Oh, he went upside down. Ooh. Let's see what is going on here. So if it's 1, it just is exactly what it was. But if we start to move it up just a hair, let's say A equals 2. What actually happened here is that everything is now twice as high as it used to be. We used to be at 1, now we're up at 2. If we're at 4, now we're up at 8. If we were at 9, we used to have the point 39. We're now up at 18. So this one actually makes it twice as high as it used to be. It looks thinner, but it's actually taller, even though that sounds kind of weird. So the X moves it left and right, or up and down. The K does. The H moves it left and right. And then the A, if we were to say instead of a 2, take it back to where it normally was, or make it shorter, 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 shorter. Pretty soon, if A is 0, it's gone. If A is negative, it points downward. Fascinating. Okay, let's go look at a couple of examples. That was like the coolest thing ever. You can actually move it based on these numbers. So here's the original x squared, this normal just U shape. Oh, I didn't get down enough. There we go, going through 0, 0. There's that U shape. This guy says we move 4, but when it's next to the x, it's in the opposite direction. So down here at -4 is where it would be. So that moved it that way, 4. And then this guy moves it down 2. So it's right here and heading up. Isn't that pretty cool? So to find the vertex, we know that it's -4, -2. That's pretty cool. And then the Y-intercept, same thing, f of 0. There's no easier way around that. You stick in 0 there. 0 plus 4 is 4. Squared is 16 minus 2 is 14. So 0, 14 is going to be the Y-intercept. That still is the case. Now X-intercepts, when we stick in 0 for Y, we have 0 equals x plus 4 squared minus 2. Notice we're already in a completed square form. This actually makes it really easy. Add 2 over here, x plus 4 squared. There's an equal sign there. Square root, plus or minus, and we are at x plus 4 equals plus or minus square root of 2. Subtract 4. Minus 4 plus or minus square root of 2 equals x. So yeah, our two x-intercepts are -4 plus the square root of 2 and -4 minus the square root of 2, comma 0. And that's these 2 points right here. And you'll notice -4 is right in the middle, just like it always is and always should be. And then we went up the square root of 2 minus the square root of 2. Okay, just to summarize what happens when you have an f of x in a perfect square form, we get f of x equals ax minus h squared plus a k. What do these three numbers do? With that minus sign right there, this h moves it left or right, and the vertex is hk. That's a positive h, k, because it moves it the opposite sign of where it went. And the k moves it up and down. The a just moves it stretches it vertically, so it's stretched up high or low. So the vertex will be the hk. Okay, so let's give you a chance to do some by yourself. To the boards! Here's some for you to do on your own. Go ahead and write these down. Pause the video. Give them a shot. Work through them the best you can. And you still have to do the vertex and the intercepts. Then press play when you're ready to move on. Okay, welcome back. Here we're going to slide these around. We're going to take the fundamental function x squared, and it's going to look like this. Good. Okay, so now what happens when we start doing stuff like this? So this guy right here, that's going to move it 3 opposite of what it says. So it's going to move it 3 this way. Yeah, so this is going to start off right here. Now I'm leaving it as a really light color so you can see, so it doesn't boggle up with what's going to happen later on. And this minus 2 does what with it? That moves it down 2. So we're down right here 2. That's right. Okay, that's good. So let's turn on the bright colors again, and that's where we ended up. Didn't quite cover on that guy, but we have this point was 3 over, 2 down. So there's the vertex. Let's get the Y-intercept. No, the X-intercept first. The Y-intercepts, you're right. F of 0 equals 0 minus 3 is negative 3. Squared is 9. Minus 2 is 7. So that point right there, not drawn to scale. That point is 0, 7. Great. And these X-intercepts, let's find out where they are. Stick 0 in for f of x, and we get 0 equals x minus 3 squared minus 2. Add 2 over. 2 equals x minus 3 altogether squared. Square root both sides. Don't forget to plus or minus. And then we have x minus 3 equals plus or minus square root of 2. Add 3 to both sides and we get x equals 3 plus or minus square root of 2. So this guy is 3 minus the square root of 2, comma 0. And this one is 3 plus square root of 2, comma 0. Is already in a completed square form. Excellent. All right, let's try the next one, number 2. Let's start out with our little x squared thing. There we go, and there we go. Dang, I just can't draw a good parabola. You know what I'm talking about? All right, so x plus 5. So the plus 5 next to the x is going to move it to the left 5. So it's going to look like this. Oh, there we go. So this is out at negative 5. Now this 2, that 2 is going to do something right there. That 2 is going to make it 2 times as tall. So where we used to be up here, we'll be up there. Where we used to be up here, we'll be up here. And so it's a long, skinny guy that got stretched twice as high up into the sky. Even though it goes on forever, every point is now twice as high as he used to be. And then the last one, what does that minus 4 do over there? Well, it drops it down 4. So we're right here down at 4 and really tall and really tall. I wonder where he comes into the Y-intercept. We'll have to find out in a minute. All right, is that the last thing? Yeah, we got all of them. So let's do that in a dark color. So it's going to look about like this. And that's going to curve and go up like that. So it was x squared, moved over there, twice as tall, and down. So this point is 5 to the left, twice as high, and then 4 down. So the vertex is right there. Notice that this is really easy as a vertex. And that's how they do it. It's the opposite of this one and then that one. So then let's try to find the Y-intercept. So g of 0 gives us 2 times, now when we stick in the 0, we get 0 plus 5. That's 25. Yeah, after squaring it, minus 4. 2 times 25 is 50. And 50 minus 4 is 46. Yeah, g of 0 equals 46. So we're way up here, 0, 46. That's the Y-intercept. All right, now let's try these X-intercepts right here. What are those 2 points right there? Let's stick 0 in for g of x. Yeah, about right there. 0 equals 2x plus 5 altogether squared minus 4. Add 4 to both sides of the equation. We get 4 equals 2, parentheses, x plus 5 squared. Divide both sides by 2. And yeah, that just cancels. And we get 2 equals x plus 5 altogether squared. Square root both sides. Don't forget that plus and minus. And we get x plus 5 equals plus or minus square root of 2. Subtract 5 from both sides and we get minus 5 plus or minus the square root of 2 equals x. So that guy's negative 5 minus the square root of 2. And the other one, 0, negative 5 plus the square root of 2, 0 are the 2 X-intercepts. Marvelous. Let's try number 3 now. Okay, so h of x equals 1/2 parentheses x plus 3 altogether squared plus 8. Oh boy, what happens with this? Okay, so we've got the regular one, y equals x squared right here. Man, we always make it a little fat on that left-hand side. Can't believe that. All right, so What does that x plus 3 do right there? That plus 3 moves it to the left 3. Let's draw that in, left 3. And so we'll be back here at negative 3 with a normal looking, yeah, perfectly nice. That's a very good parabola. Okay, now what do we do with the 1/2? The 1/2 will make everything 1/2 as tall as it used to be. If you're up at 10, you're now down at 5. If you're at 2, you're now down at 1. So it makes it look really short. Comes off looking very fat, but it's not fat. It's under tall. It is shortened. Yeah, just like that. So what does the 8 do now? The 8 is going to bump it up 8. So all the way up, yeah, about right there. So now it's a fat parabola, short parabola, I should say, but way up there at 8 high. And that was the last one we had. So let's go ahead and make that one darker. Yeah, this is 8 up. And the vertex, were negative 3, and then we went up 8. So that vertex is a negative 3, 8. Excellent, excellent. So we got that one. Now we got to get like the Y-intercepts. But hey, these X-intercepts, we're not going to hit anything down low. Oh my word. So let's stick in h of 0 and see how high we are. 1/2, 0 plus 3 squared, plus 8. 3 squared is 9, times 1/2. That's like 9/2, 4.5 plus 8 is 12.5. Or you could say 25 halves. That's okay. But yeah, we're way up there. 0 and 25 halves. Let's write it like that. Okay. So the X-intercepts, yeah, these don't cross the X-axis. We don't have any. But we can still find out what they are, even though they're imaginary. Let's try it. So we get, yeah, 0 equals 1/2 x plus 3 altogether squared plus 8. Subtract 8 from both sides. Good. Plus 3 altogether squared. Then we times by 2 on both sides. Good. And square root both sides, plus or minus. What's the square root of negative 16? That's 4i. Yeah, 4i. Don't forget that plus or minus. And so now we're left with the x minus 3 over there. Add 3 to both sides. Oh, shoot. Those are plus 3's coming down there. So we had to subtract 3 from both sides. Yes, negative 3 plus or minus 4i is what the x's are. And you'll notice as complex roots, as numbers, we don't hit the x-axis at all. It's not even close. Good. Now you can do some on your own.